Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty and today we'll discuss about the Ramjet engine. The Ramjet engine is the simplest possible air breathing engine, and Ramjet engine has certain advantages over other engines. One of the problems that we encounter when you are considering the different types of gas turbine cycle as well as some of the jet engines like turbojet and turboprop engine, that we require a compression, and compression is not a power generating device, rather it's a power consuming device. So some of the power that is developed during expansion is actually utilized to run the compression. So when we are talking about the Ramjet engine, it is a type of engine which doesn't require a compression. You can see the different components of the Ramjet engine. You do have two diffusers. One is a supersonic diffuser, followed by a subsonic diffuser, followed by combustion chamber or combustor, and then you have a nozzle. And these two diffusers, they do the same work as that of a compression of a gas turbine cycle. In gas turbine cycle, first air is taken in, it is compressed in the compression, then it is taken to the combustion chamber. In the combustion chamber, heat and fuel are added to air, and as a result there is a significant increase in its pressure and temperature. Then it is taken to the expander, where it expands and does mechanical work. And part of the power that is developed in the expander is actually utilized to run the compression. In diffuser, you are not required to do any work to achieve the compression. So how actually the system works? First, air at very high velocity enters the supersonic diffuser. Diffuser is a smoothly varying section where the kinetic energy is converted into pressure energy. When I am talking about a supersonic diffuser, means the speed at which the fluid enters the diffuser is much more than the velocity of the sound. So when it is above the velocity of sound, we call it supersonic speed, and the diffuser so used is called your supersonic diffuser. Then you have a subsonic diffuser. In subsonic diffuser, the speed is further reduced and there is a corresponding increase in pressure. Both in supersonic and subsonic diffuser, the velocity is reduced or the kinetic energy is reduced and there is increase in pressure energy. Of course, not the entire drop of kinetic energy is converted into pressure energy, because you do have shocks and other losses. Oblique shock and normal shock have been shown, and apart from that, due to other factors also, the drop in kinetic energy is not completely converted into corresponding increase in pressure energy, but still there is a significant rise in the pressure energy at the expense of the kinetic energy. Then it is taken to the combustion chamber or combustion, where fuel and heat are added, and due to this very high temperature is developed, and then it is taken to the nozzle. Nozzle actually is a smoothly varying section which converts the pressure energy into kinetic energy. Due to the diffusers, we do not require a compression, so the amount of temperature that can be attained in the combustion chamber is very high. As a result, we can develop more power, and a temperature close to 2000 Kelvin can be achieved in the combustion chamber. And after that, it is made to pass through the nozzle where it undergoes expansion and huge amount of kinetic energy is developed, or the velocity with which the working substance leaves is very high. And this velocity is much higher than the velocity at which the air actually enters the supersonic diffuser. And due to this, thrust is developed just in the opposite direction, which actually helps in moving the ramjet engine. And as far as the air is concerned, the air flow rate may be MA and the fuel air rate may be MF. And considering the conservation of mass, the amount of gas or the exhaust is the summation of mass of air entering plus the fuel, that is air rate. So combustion is a continuous process. Continuously air is being drawn and it undergoes compression, and this type of compression is what we call your ramped compression. The compression that is taking place in the diffuser is your ramped compression. And you can see the different points. The entry, you may consider the point just before the entry to be 0, this to be 1, this to be 2, this to be 3, this to be 4, and this to be 5. So section 1, 2, you can consider this to be supersonic diffuser, 2, 3 is subsonic diffuser, then 3, 4 is your combustion chamber or combustor, and then 4, 5 is your nozzle. Another thing that you need to remember, that the speed of the air is to be significantly reduced, maybe to less than 0.2 Mach. That means 1/5 of the velocity of sound. Otherwise, what will happen? It will blow out the flame. So you will not have the desired combustion. So it is very, very important for this much expansion to take place, and the speed should be reduced to 0.2 Mach to ensure smooth combustion in the combustion chamber. And then another thing that you need to understand, that when it comes to your ramjet engine, it is not a self-propelling engine. Why it is not a self-propelling engine? Because the air has to approach the supersonic diffuser at a very high speed, in supersonic speed. So it requires a launching device so that the relative speed between air and the ramjet engine is significantly increased. They approach each other at a very high speed. So it is not a self-propelling engine. Coming to the thrust that is developed, it is observed that maximum amount of air is drawn into the ramjet engine when it is at sea level. Once you go high up in the altitude, the thrust is actually do get reduced. But as far as the speed is concerned, at higher altitude, the speed is significantly increased, because as there is less amount of air, there is less resistance to the motion of the aircraft. The ramjet engine has certain advantages as well as disadvantages. So one of the major advantages for which the ramjet engine finds some application is that it doesn't have a compression. So no portion of the power is utilized to run the compression. And apart from that, as you do not have a compressor, you can achieve a very high temperature, which ultimately helps in improving the performance of the engine. Then, as compressor is not there are no moving parts. So maintenance of moving parts is not required due to absence of this compression. But it does have some demerits also. I have told you that it is not a self-propelling engine to begin with. So you have to use a launching device to give it a motion, and once it starts operating, it becomes self-sufficient. And another thing that I have told you, that we can attain a very high temperature which helps in improving the fuel economy and its performance. But at high temperature, dissociation of the molecules, fuel molecules may do take place. So some of the power that is developed may be utilized or wasted due on account of dissociation. The Ramjet engine actually finds application in missiles and other military aircrafts, and I believe that today's lecture on Ramjet engine would be extremely useful in understanding the concept of this type of jet engine. But if you have any doubt related to this, please do put questions so that I will try to answer. You can always refer to my earlier lectures on gas turbine cycles as well as the turbojet engine, and you can compare the different components of the Ramjet engine and the difference in operations of the Ramjet engine with the turbojet engine. Thank you all for watching this video and having the patience to watch the same. I would request you to subscribe to my channel if you have not done so till now. I would further request you to share this video with your friends and relatives to improve its visibility. Hope to see you soon for another lecture on my YouTube channel, Erudispace.